Hello and welcome to the Complete Noob's Guide to Cloud Security. I'm the noob, or maybe I'm the person that's going to give you, the complete noob, a guide to cloud security. Or maybe I'm going to give you, the noob, a complete guide to cloud security. Either way, that's me. So I am currently an O365 and Azure sysadmin who dabbles in security. And because I'm a total glutton for punishment, I'm also a part-time grad student in computer science, which, let me tell you, great insights, no spare time. I also moonlight as an organizer for the DEF CON Village, Blue Team Village. We put on a lot of Blue Team related security talks, workshops. We've appeared at DEF CON, Grey Hat, and a number of other conferences, and run small programs as well. Very active in that community. I consider myself a jack of all trades in that I like to dabble in a lot of different things. And in some ways, I'm a mile wide and an inch deep. And in some areas, I'm about 2 miles deep and an inch wide, if that makes any sense at all. I have a lot of hobbies, most of which involve heavy investments of money that I don't really have quite yet. And quarantine has given me a good opportunity to explore a few things like woodworking and jigsaw puzzles and baking. And also in my spare time, a little side of cloud security. So a little bit of background that I think is relevant to this talk. I came from an interesting background. I originally dabbled in, actually in law. So I was a legal secretary for a number of years, and then kind of accidentally wound up kind of dropping into IT as an AV person and a help desk support specialist before moving into desktop support as well. And then eventually into my current job as a sysadmin. So I consider myself security adjacent, and being in O365 especially gives me a good perspective on one application of the cloud, although we won't be really talking about O365 today. So on the slide, I've left all my relevant information. I'm stalkable everywhere. I've actually now completely doxed myself on the internet. This is the first time I've mentioned my real name in a talk where I'm using my handle as well. So it's kind of a fun first for me. So without too much further ado, I want to talk about some fundamentals of cloud security. And I'll be quite honest, coming up with this was quite a haul. There's a lot to cover, and there's a lot of things that could be considered fundamentals. But I'm going to break this down into kind of a couple key things to keep in mind before I go into the actual fundamentals in terms of the technical aspects in this talk. So cloud services are not, I'll say that they're not put together in exactly the same way as the various services and technical elements of your normal IT infrastructure. So I like to think of this as components based. And when you move into cloud security, you have to change your mindset a bit to actually accommodate the idea that cloud services are components that you can tie together with internal APIs. And that stitching together components is kind of a theme that we'll keep coming back to and that will pop up in this talk. One major suggestion I have for anyone that's interested in getting into cloud security, learn some code. So coding is key because in the cloud, infrastructure, management, and all of these services that you're using to replace on-prem infrastructure, they're kind of getting closer to application security, especially since they're using APIs in that component methodology. So inevitably, you might wind up having to actually collaborate with your dev team. And when that happens, it's incredibly helpful to have at least a base understanding in code. And that will also later feed into any exploration that you do of things like automation and orchestration, which is something we'll touch on at the very, very end of this talk. It's not necessarily a noobs kind of topic. And the last thing that I really want to stress, and I will continue to stress at every opportunity, is to be flexible. The cloud changes all the time, and everything that you put in place in the cloud is not a set it or forget it thing. So when you move to the cloud, your infrastructure, your applications require constant reevaluation. The cloud will change whether you're ready for it or not, So be prepared to lose a little bit of control, to adapt your mindset to accommodate new ideas, new projects. And lastly, definitely not least, today actually was a great day to record this talk because we wound up having a pretty massive AWS outage. And that was the outage of US East 1. Impacted a lot of services. And key enough, one person who posted on Twitter that was actually not affected by this had a replication in a different region. So you kind of have to prepare for the inevitability that things will be outside your control, but there are ways that you can actually adapt to them as well. So keep that flexibility in mind. It's going to be incredibly important. So the next thing that I want to talk about is probably the underpinning of any cloud security talk. I've kind of jokingly said that you can't have a cloud security talk without talking about the shared responsibility model. And this is basically the idea behind this is in the cloud, you have varying levels of accessibility and control. So if you want to take your normal defense in depth approach and apply it to layers, you have to have an understanding of the fact that different services will give you these differing levels of access and control. So your decoupled components, in essence, are going to create this new perimeter. So if you look at this graph, this is actually Microsoft's graph, which I actually like better than AWS's, but don't tell them. You can kind of see that the level of access that you have to something, the lower it is, the more you're relying on the cloud to take care of certain things for you. So your cloud provider may cover the bulk, if not almost the entirety of infrastructure. You are always responsible for your data. Whatever data you put in any cloud service is your responsibility to protect in whatever way is accessible to you. And again, this comes back to that having that flexible mindset in that, you know, when you're approaching a new service or resource that you have not used before, you need to be prepared to evaluate where in this spectrum it actually falls. So I'm going to give a little example that I'm going to use a couple times. I'm a huge Star Trek nerd. That's my enterprise badge from DEF CON. It's really cool. It has blinky lights. I love Star Trek. So I was trying to come up with some way to actually take some of these concepts and translate them into something that's a little bit more accessible. So let's say we have the Star Trek Swag Station 9. I'm a consumer. I love Star Trek. I want to buy some merch. So we have a very simple architecture for a web store. And as you can see, we have like some user interface. Probably should just be like the actual front end of the website, but I'll call it a user interface here. So I want to take this and I'm going to apply it to that shared responsibility model and the infrastructure as a service, platform as a service, software as a service kinds of levels that were described in that shared responsibility model. So I'll start with EC2. EC2 is basically a VM. You can actually manage the OS of an EC2 instance, and you should. That is your responsibility. So this actually falls in the infrastructure as a service kind of category. And then the next thing would be these RDS databases. That's AWS's relational database services. So let's say we have a customer database and an HR database. So that's kind of platform as a service. It's not a service where you need to be concerned about managing the operating system. So that's where that falls. And then lastly, we have a Lambda, which is a serverless function. Function as a service wasn't really described in that first shared responsibility diagram, but it kind of falls between software as a service and platform as a service. It's kind of how it's described. It's a little nebulous, so you have to keep in mind to be flexible even about how services are labeled. But the idea is in a Lambda function, you manage the code, you manage what libraries you import, but you have very limited control over anything else. So that's where that falls in that spectrum. Now, the next pretty large area that I'm going to cover is going to be identity and access management. And if you know anything about security, you'll understand how important this is. So in AWS, And this is somewhat similar to other cloud providers as well. I originally would have loved to put in a little quick discussion about role-based access control in Azure, but I unfortunately, it was just a lot to put in here, so I decided to skip it. But essentially, the individual element of this is a user or a service. Any service like an EC2 instance can adopt, or it kind of can be its own IAM user, if you will. So thinking a little bit more big picture, I'm going to say that you can use IAM users for quite a large set of functions across an account. In AWS, you should be configuring anyone who has access to your account as an IAM user. So if you know the basic idea of, lock down your root account and throw away the key, same thing applies in an AWS environment. So you want to have IAM users be the primary way that you access anything to do with the account, billing all the way down to a user who's using or managing, a subset of instances, for example. So you use IAM users primarily for access, and you want to apply the principle of least privilege. So let's take a look at this graph, or this little, I don't even know what to call it, little happy diagram. I'm going to use the analogy of wearing a cape. That's what those little triangle things are supposed to be. I don't have the best online drawing skills, so bear with me. So essentially, in AWS, a user or a service adopts a role or assumes a role. And these roles, you can let a user assume more than one role. Sometimes you want multiple roles so that one user has access to a few different roles, but a different user has access to a different subset of those roles, or so on and so forth. So if a role is a cape, there's something attached to it that's called a policy. And the policy lays out in pretty good amount of detail what permissions that user has to do anything. And you can get very granular with this, and you absolutely should. So the policy is attached to the role. In this case, maybe like a permission slip is attached to the cape. The user puts on the cape, the user assumes the role, goes to a service, and that service basically determines whether or not that user is supposed to be doing the thing that they're trying to do. So the best example of this is just to look at the code itself. And this is JSON. Like I mentioned, you should be getting used to code. You should also be getting used to JSON and also YAML. Maybe we'll touch on that a little bit more later. But basically, this lays out the permissions that whatever user has, that if they assume this role, they have these permissions. And you'll also notice there is resource star. Do not do this. This is bad. Do not do it. Back away. 0 of 10. Do not recommend. So that's a whole other conversation. But let's take a look at this, how this actually applies to our Swag Station 9. I'm only going to look at a quick subset of this. So first off, I want to buy a batleth because I'm a Star Trek nerd, let's face it. So my EC2 instance is going to assume a role in order to trigger the Lambda that processes my payment. So it has a role that specifies permissions to do that exact function on that exact resource. And then the Lambda returns a result. Great. EC2 assumes another role to save the result to the database. And there you go. That's my purchase. And that's what that looks like. So let's go back to how star is bad. Star is always bad. This is like a tenet of cybersecurity. So in theory, I'm actually going to just use the role from the EC2 service to access the customer database. Maybe I want to save my payment information. Well, in practice, if I have star and there are no other permissions boundaries set up, I could also access the HR database. That's obviously a no-go. So putting that aside for just a moment, well, we'll probably come back to that at some point, especially the idea of star and all of that. I do want to touch on networking, which is another important topic. So AWS breaks out regions, like I mentioned earlier, it was the US East one that went down. So you probably should be using a little bit more segmentation than just region. But essentially you have a region and that is where an environment lives. And then after that, you have availability zones. And this essentially is what it sounds like. It's intended to be somewhat of a failover and also provides a little bit of an extra perimeter. And then you have a VPC that spans availability zones, but is limited to your specific region, whichever one you're using it. And then beyond that, you have public and private subnets. And we'll talk a little bit more about those in a second. So one thing I want to point out here is I actually talked to a good friend of mine who's a network engineer. And I was asking him about what problems he sees with when people are moving on-prem infrastructure into the cloud. And the first thing he said is that simple is better. So complexity in the cloud in networking does not necessarily mean it's more secure. So if you look at this basic diagram, this is kind of the root of what you want to know to manage instances. But there is a lot of other options, but you don't want to get too complicated with it, especially when you're moving from on-prem to the cloud. And the other thing he said is that do not expect to reproduce your on-prem architecture in the cloud. This is software-defined networking. It's not going to work exactly the same. It's also not going to work the same between AWS, GCP, Google Cloud Platform, and Azure. They all work differently. So you use VPCs and accounts as boundaries. In our sample architecture, this means that by putting our internal HR application in its database in one VPC and our public-facing app in a different one, we've implemented a little bit of segmentation there, which is good. And a private subnet is basically set up so that there's no direct route to reach the internet from that whatever resource is in that subnet. So in this case, our customer database only needs to talk to the other internal elements. For example, in this case, the web server that is running the rest of the application. And then the public subnet contains resources that actually do need to communicate to the outside world. So we have a third-party payment processing service that our Lambda uses, and then we have what I call the user interface, but realistically, it's just the end result being returned to the user themselves. So another important aspect of VPCs and networking and resource segmentation to understand that's specific to AWS is going to be security groups. Very, very, very important concept to keep in mind as well. So security groups span all availability zones in a VPC. So let's say I have multiple resources in multiple availability zones because I want things to fail over and I want that redundancy. I can actually put both of my EC2s in a security group and then both of my databases in a different security group. And this is probably not the most accurate example here, but I named one DB group. It's actually the EC2 instances that need to access the database. They need to send information. So my security group B, where my databases actually live, are set up to only accept connections from other of those EC2 resources in that security group. And that's definitely a solid way to implement resource segmentation and a bit of a perimeter as well. And it's also important to note that for VPCs, security groups, and these resource segmentation tools, you can actually use tags. And that's something that's highly recommended that you do. It's not only a way to track, but also to set conditions and limit what you can do using those policies that you attach to roles. So the next section I'm going to talk about is data protection. This is a huge area. I mean, there is just so much that we could potentially cover in this. So I'm going to try to kind of keep it a little bit higher level. Essentially, you should always encrypt your data. You should encrypt your data in transit. You should especially pay attention to encrypting any personally identifiable information. And AWS has a couple different ways that they let you implement this. So going back to the idea of being flexible and thinking of in components and looking at things through the shared responsibility model, there can be some areas in AWS where you're allowed to do more than others. So if you notice at the bottom, there's the infrastructure as a service EC2 accepts both HTTP and HTTPS traffic and defaults to not actually to be encrypted. These are options that you can set. You have a lot more control in this area than you do, for example, with Lambda, which actually requires HTTPS only traffic and encrypts its environment variables. There's no permanent storage in Lambda, so there's only RAM storage, and that's why that's noted there. So this is a specific example for S3 buckets. I could probably go off on a little rampage about S3 buckets, but I'll go ahead and save that for a little bit later maybe. But you have a couple different encryption types. So AWS gives you the option to let them manage everything. They give you the option to actually do your own encryption, where you manage the keys, but they manage the actual encryption part. So there are a couple different options. They change a little bit per each service. AWS also offers its own key management service, KMS. It does come at an extra charge though, so you always want to make sure to be aware of that before going whole hog and deciding to use KMS for everything. And actually, before I move on, one thing I do want to point out, this graphic here is an example of envelope encryption. So this example is specific to S3, but essentially what it's doing is using a master key to encrypt a data key. And those data keys are actually rotated as well by AWS. And it actually stores the data key, the encrypted data key, with the encrypted data. So you need the master key to unlock the data key to unlock the data. So it's kind of an interesting system. Like, again, there's a lot to go into here, so I'm going to try to keep that as brief as possible, as can be possible for this expansive a talk anyways. And then one final note I want to make about data protection before moving into a couple other sections of this talk. So I am not normally the kind of presenter that gives you a wall of text. This is not something that you should be reading and writing furious notes for. Really what I want to get across here is that compliance is always your responsibility. And cloud providers usually offer some amount of HIPAA compliance in that they are ready to be HIPAA compliant. But in order to actually be HIPAA compliant, you need a business agreement with that company before doing so. They have all the controls in place. And for most services, as long as you configure according to what HIPAA requires and have a business agreement, then you would be HIPAA compliant. So for every service that you look through, it's important to keep in mind that HIPAA compliance actually varies across services. And that's absolutely something you should research before just saying, oh, Azure is HIPAA compliant or AWS is. So it's just one extra thing to keep in mind if you're someone who works with compliance on a regular basis. And then the next big area that I'm going to tackle is visibility. And this comes down to logging and monitoring. Sorry, I mostly do panels, so I'm not used to talking in one straight go. It's quite fun, actually. So I hope you had time to read this slide a little bit. And to be honest, if you're looking at this and you've dealt with any amount of logging, whether in the cloud or not, there are probably a couple things that you recognize here. So visibility applies to applications, to networks. You can approach it from an event perspective, intrusion detection, also from the perspective of analyzing behavior over time. So you always want to consider what your objectives are before deciding what tools you're trying to use, whether that be log collector SIMs. You can incorporate CASBs with cloud vendors as well. So there are quite a few challenges here. I've actually had full panels just talking about logs, and we definitely touched on some challenges in the cloud. So one of the main ones is that log formats can be inconsistent by resource, especially when you have a mix of on-prem architecture, cloud. Then you get into multi-cloud where you have log sources from multiple different cloud providers. Format is going to be an issue, and trying to normalize that is a huge challenge. Completeness varies by service. AWS especially has a lot of new services coming out, and at times they don't default to being as complete as you would hope. And then the last of the challenges is actually correlating logs across multiple services. So we'll briefly touch on microservices a little bit later in this talk, but when we're talking about components-based architecture, when we're talking about trying to create infrastructure that crosses between different services. So in our example, we have EC2, we have Lambda, we have RDS. Correlating logs across all of those different components it's a challenge. And I can't tell you that I have exactly the answer for it quite yet, but it's definitely something to keep in mind. So a couple of approaches I thought about this, and this is more of a thought process than a technical focus. So the first thing is to actually analyze what you have. Collect logs, look at them, figure out what the new normal is. Once you have a baseline for what normal behavior looks like, it's a lot easier to go ahead and filter and figure out what is actually important. And then the next thing to do is expand on that. Take what you know is good behavior from your limited set of sources and add something more. Pull in on-prem a little bit more, or try to start that correlation process. And another note I want to make about this is you want to basically look at log sources from every layer. You want to have logs for billing. You want to have logs for any top-level account use, all the way down to the resource, to the OS if you can get to it. So logging and monitoring in the cloud doesn't end at API calls over to EC2. It also should include logs from the OS itself, because you still have control over that. And then the last approach for that is reassess based on your needs. Fine-tune it, adapt it. This goes right back to flexibility. Cloud providers add features all the time. And while that's great, it requires some amount of kind of keeping up with what those changes are and what they can add, and also what they can break in your infrastructure. If you need a third-party software to help manage those, that reassessment is the time to look into it and figure out if it's right for your needs. And you can also use tools in the cloud like tagging to make your log collection analysis better. Oops. Right. That's not what I wanted to do. All right. So let's talk a little bit more about some blogging stuff in AWS. Pretty much any cloud security talk you're ever going to go to, at least at a fairly introductory level, is going to talk about Cloudtrail, and it's going to talk about CloudWatch. If those are not addressed during a pretty basic cloud security talk, I would be extremely surprised. I'm also going to throw in there VPC flow logs, because if you're interested in that networking side of things, it's a great thing to keep an eye on. So all AWS services and resources communicate with each other via API. So you use Cloudtrail to log those calls. Cloudtrail defaults on for many services, but not all. So whatever you're using, you want to make sure that you understand what it is doing and what it is not. It's also highly configurable. So you can add a lot to it, including, if we go back to that learning code, the Boto2 library is a Python SDK for AWS. You can actually incorporate extra logging and build it right into Cloudtrail. There is the option to do that. This works really well for Lambda. You can basically include that while you're actually executing a Lambda function, which is pretty cool. Cloudtrail defaults storage to S3, but you can also feed it into CloudWatch. And CloudWatch you can actually use an API with as well. So you can group by services, resources, group logs across regions. You can use tags. There's a lot of other really cool things that you can do with it. So for VPC flow logs, this basically is going to log any behavior from network interfaces, which can be attached to any resources. And it's not just for use within a specific VPC, but other services. I think RDS is one of them. actually lets you track the network interfaces using VPC flow logs as well. And again, you can use tagging with this, which is pretty cool. And then the last one, and we will touch on this a little bit more as well, is you can monitor using CloudWatch. So you can collect data, you can analyze. There's some pretty cool dashboards you can use, insights. This is where you would build out alerting. I found it a little bit janky to work with at first. It takes some getting used to, and it can be a little bit limited in what it can track. But the nice thing is, if you're able to build something like a metric filter, you can essentially have it automatically, kick off an alert. I think one of the ones I had set up at some point was like a change to a security group, which is absolutely the kind of thing you want to be instantly notified of, or within a few minutes at least. So let's take a look at what this looks like in our sample Swag Station 9 architecture. So I've got a couple different things going on here. I built out my public and private subnets. I have resources in 2 different VPCs, so I have a little bit of a perimeter going on there. Well, let's say I want to log this. So let's see what that looks like. So first of all, I can add VPC flow logs, and this can actually track the connections between these different services, or the EC2, RDS, and Lambda as well. And I'm just looking at this one part of the example. So, oops, got a little ahead of myself there. So the next thing you can do is, so I mentioned in Lambda, you can use that Boto3 library. I can actually add to the existing Cloudtrail logs that get generated. So if I want to make some other more detailed logs, I can actually use the Lambda event data or information that was sent into the Lambda when it was executed. I can actually add that or make decisions about that and incorporate it into the Cloudtrail logs. This has a lot of potential. I need to play around with it more. There's just so much to learn in this area that it's just impossible to have time for it all, but it is pretty cool. And then the last thing is you can add a CloudWatch trigger for, let's say, unusual traffic. So maybe my site is has some weird amount of orders or a large spike in activity that just does not feel normal, because I'm a tiny little boutique Star Trek swag shop. And then the last thing I do want to point out on here that I did forget to kind of point out is I'm running an EC2 server. I have access to the OS. So I can actually use or pull in logs from the actual OS of my web server. I can pull that into Cloudtrail and also port it over to CloudWatch. So there's a huge amount of potential there as well. So I had I originally had some plans to go into a little bit more depth with some of these tools, but the problem is there are so many, and they're creating more of them every day. Some of them work really well. Some of them probably need a few more months out and some tweaks before they're truly effective. And it's really up to you and your organization and your situation to figure out what's going to work for you, what works for your organization. AWS has a ton of offerings, but pretty much all of these are paid services. And if you're a small company, you don't necessarily have all the money to just invest in all the fancy tools that AWS can offer. What if you decide, well, let's be realistic. What if one of your C-suite decide that we should move over to Azure? What are you going to do? So it's best to try to assess what the future holds before investing all in these expensive services. And there are some great ones. Honestly, KMS is phenomenal, and I highly recommend it. I've worked with it a little bit more in depth than some of the other ones, and there's a lot that it can do. It's really powerful, and it makes things a lot easier. GuardDuty is pretty well regarded. Control Tower has generated a ton of interest. But it's key to think about what you want to do and investigate and see what your needs are as well before going whole hog into investing in services. There's also a ton of third-party and open source tools out there, many of which may be multi-cloud. So if you are that company that wants to invest in Azure, then it's absolutely worth looking into third-party or open source tools that address that better than something that's dedicated to AWS. So we're now past the completely noob level of this talk. And actually, the more I talk, the more I realize it's turning into the Noobs Complete Guide and not the Complete Noobs Guide. So I apologize if you're a little lost. Just know that there is a ton to learn. You will never get bored. You will never run out of things to learn in cloud security, and that's, to me, is what makes it so exciting. So I'm going to talk about a couple other totally exciting things, well, to me anyways, because I'm a huge nerd, that are commonly connected to cloud security. And I mean all these super fun things like serverless, microservices, containers. I think that when we talk about cloud security, one of the first things that comes to mind is containers. So I'm actually going to start with microservices, and this is an area that I've explored a little bit more than some of the other areas. So microservices is kind of a cloud native topic, I feel like, or at least it's a very good fit for cloud talks in general, or cloud architecture, because the idea is microservices is a design pattern. It is a methodology for creating applications, and also it can be used for infrastructure as well. It is a collection of loosely coupled components. Now, I know that at the beginning of this talk, I actually basically described cloud services as kind of loosely coupled components. This is all components-based architecture, so it makes sense that microservices fits in really well with cloud architecture because this concept is shared between them. But microservices also shifts a monolithic architecture way of thinking about an application to something that's a little bit more flexible. And it can make upgrading much easier because when you swap out components that have the same functionality, it works a lot better. This is actually comparable, if you have any experience with programming, to just the use of functions or the use of modules or a lot of the concepts that come with object-oriented programming. So an example of this, and I realize this is like the most non-color scheme abiding slide out of all of these. I actually stole it from another presentation that I did a while back. This is just a quick overview of kind of what this monolithic architecture looks like versus microservices architecture. And if you look at the right side of it, it does look a lot like kind of a cloud architecture. It's very similar. So it's, it's really well suited for the cloud. And microservices is also commonly used in combination with containers and serverless functions, aka Lambda. So what's serverless? Well, let's be realistic. There are servers in serverless. They're just obfuscated away from you. You have no interaction with the infrastructure. So in essence, the idea behind this is a place for programmers to create one function to execute something where there should be an input and a result. There's one focus for it, where they don't have to worry about configuring a server or an operating system or even actually installing libraries. All of that is done behind the scenes. It simplifies the development process for developers and can be used for any number of normal IT-related functionality that you could possibly dream up. It's event-driven, meaning it's triggered by API access, a call. It kind of sleeps and then wakes up when you need it. And I could go completely on a rampage about that, but I think I'll try to hold off a little bit and not get too crazy with it. But really the idea is it's a very simple limited access model. And it's also primarily accessed with APIs. So that's generally the only way that you're going to be able to access it aside from the initial configuration. And this is AWS's Lambda is basically probably the best known example of what a serverless function is, and also kind of coined the phrase function as a service, which is somewhere between that software as a service and platform as a service. So again, limited amount of access. So this is an example of putting together microservices application with serverless functions. Essentially, what you can do is create a series of steps, and then for, if this happens, you move to the next step, trigger the next Lambda. Step functions is a pretty cool AWS service. It's definitely more on the development side than the IT side, but it's still an interesting kind of example of a way to stitch together microservices applications. And then last, but definitely not least, let's talk about containers for just a minute. And I will freely admit that this is not my specialty, but it's, again, a really interesting area to dive in much deeper to if you have the time, energy, and if you're interested in this. So essentially, a container is a standard, well, this is actually, Docker describes it as a standard unit of software that packages up code and its dependencies so the application runs quickly and reliably from one computing environment to the other. Essentially, the idea behind this is to have a portable bundle of code that can run whatever application you need. It's extensible, it's flexible, again, fits really well into the cloud model overall. And it's designed to isolate processes from the kernel, to take that management of the OS away from you. And it's very lightweight, but it can sometimes give the false sense of security in that it feels like isolation should equal security, and that simply isn't really the case. And that's kind of something that that pops up every now and then. So again, I'm not completely a specialist about this, but it's definitely an area that you can really dig into. And again, I just stole this right from Docker's website, but this kind of gives an example. So in a VM, you would see a hypervisor, you'd see a guest OS, and all of that is actually obfuscated away in a container. And there are a lot of native cloud container services. I want to say Amazon has ECS, Elastic Containers Service Storage, one of those things. A lot of offerings in this space. Docker is definitely well regarded. And I played around with it a little bit. It's definitely something that's worth poking at if you have the resources to do so. So how does this all relate to security? Well, it's not automatically secure. If you're surprised that I'm saying that, well, don't be. So a couple notes about this. Container images are generally open source. So don't expect that just because it's available in the marketplace that it itself is safe. That's not always the case. So you do want to vet the container image before using it. And quite famously, you can break out of a container. Containers are absolutely not secure by default. And there are plenty of ways to play around and use that to your advantage if you're a good hacker. I'm not quite there yet. And then, so going back to this idea of microservices, multiple components is multiple permission sets. So if we think about all of the different AWS pieces that we looked at and all the connections between them, there are an increasing number of ways that we can configure roles and permissions. And if you can break out of a container, if you can break out of a serverless function, that means that you have access to any of the roles that function has access to. And that basically means that your application or your infrastructure is as secure as its least secure code and its most lenient permissions boundary. This is absolutely key. If you remember nothing else from this entire talk, this is what you should remember. It's, lowest common denominator, your least secure code, and your most lenient permissions boundary. If you have a role that has access to everything and can do everything, you can use that to make anything happen. You can create new IAM users. You can exfiltrate data all you want. You can even delete logs. So permissions is very important, especially when you move into any kind of infrastructure that is loosely coupled, like microservices, or like most of the architectures that that we've kind of poked at so far. And I actually put a call on Twitter for a really good basic level infographic. Had a hard time seeing one, but I'm not going to go through this step by step and explain what it is. So I will just say, I'm going to reiterate, it's permissions, permissions, permissions. So essentially in container security, which this specific example relates to, I mean, you can basically, have a default set of permissions, but you need to lock it down. You need to make sure that the container has only whatever level of access it needs to its underlying infrastructure then that you need. So it's always about permissions. It always goes back to permissions. So the last thing I'm going to talk about very, very briefly is orchestration and automation. And this is probably, this is an entire presentation in itself. I realize we are slipping further and further away from complete noob into Noobs complete guide category, but I wanted to at least do this topic a little bit of lip service. And the reason I say that is because these are terms that are going to come up time and time again. We're always going to be talking about how do we automate this? How can we create templates for things instead of having to individually stand up things? That's always going to come up. So automation is an incredibly powerful tool. You can take boring, repetitive tasks and basically never have to worry about them again. I often say I know I'm a programmer because programmers are lazy. Programmers would rather do 4 hours of work up front than do a 5-minute task every other day or every week. So essentially, you want to use automation to eliminate repetitive tasks. It's also a great way to standardize things that you're doing so that you have a consistent approach for pretty much anything. So if you're trying to always respond to a certain type of log, a logged incident, that can happen. So automation is a great tool. It is also possible to over automate your infrastructure. So definitely keep an eye on what is necessary and what's overkill. Orchestration is a little bit more interactive than that. It's more the management of whole systems. This is where you see things like Terraform and Ansible. Orchestration of containers, Kubernetes is one of those things that pops up a lot too. Again, a huge area we can go into. I'm not going to dig too deeply into it, but if you want to enable flexible, scalable apps and security infrastructure, then these are kinds of things that you're going to be dabbling in. And I played around with Terraform and Ansible before. They're super fun. CloudFormation, which is specific to AWS, also super fun. And they're called infrastructure as code, which is kind of its own category in that pipeline or in that shared responsibility model. So we're almost at the end. I swear I only have a few slides left and then I'll actually be done. This is actually approaching an hour. I'm pretty impressed. Also, I love this meme. This is like one of my favorites. So I just to take a step back, I know we've kind of gone 0 to 60. And to be honest, when I started out learning in AWS, I was a complete noob and I fumbled my way through learning how to use Lambda. I fumbled my way through Cloudtrail and CloudWatch and KMS and IAM roles, policies, lots of cursing was involved. It's really easy to fall down the rabbit hole when you get into cloud security. And it's also really easy to fall all the way down the rabbit hole and end up with, what we covered in our last slide about automation and orchestration. So lots out there. It's totally fine to feel like you're in over your head. So I have a couple tips for that, which I'll get to in the next slide. But kind of the other thing that I want to have you think about as a lessons learned is that you're always going to have different levels of access and control. It goes back to that shared responsibility model, the difference between, software as a service, infrastructure as a service, platform as a service. Every resource type, resource, service has a differing level of what you can actually do with it, and you should always be keeping that in mind when you use them. And you're basically designing infrastructure based on these connected components, and you have to think about what the connections are between those. And the last thing on this list that I cannot possibly stress enough is that permissions is the new perimeter. You cannot fall back on perimeter defenses without, well, in the cloud. This is not on-prem. It doesn't work the same way. So your permissions are your new perimeter, and always keep that in mind. Oops. And one of the other last things that I'm going to say here is that you kind of go through a life cycle with this. And I know this personally because I've done it a few times. So my recommendation would be start simple, go layer by layer. If your organization is just moving to the cloud, focus on getting the base set of logs in, focus on base services, learn them, learn from them, take it layer by layer, component by component, go from service to a group of services, to the account, to the big picture, constantly reevaluate. It's so important in IT in general to always think about where you are and where you want to go, and remember kind of what your idea was when you started. Has that changed? Does that mean that your direction changes? Does that involve multi-cloud? Does it involve shifting in a totally different direction? Always reevaluate and think about what you're trying to do. That is so important. And once you've done that, then you can level up, incorporate new services, incorporate new plans, find new tools, invest in that extensible, flexible tool instead of something that's limited to one cloud provider. But make sure that you do that reevaluation before you do that leveling up. Cannot stress that enough. And always prepare for change outside your control. Even though, plenty of people had redundancy in regions across AWS, well, what if they both went down? You have no way of knowing. So you should always be prepared for things to happen that you have no control over. And then the last thing is I'm going to bring it back to the complete noob as opposed to the complete guide for noobs. So I think when I started, I had a lot of ideas, and I was missing some base knowledge. So I'm going to say the biggest recommendation that I can make is to start by laying groundwork, and that means learning fundamentals. It really helps. For me, I struggled a lot with VPCs because I didn't have that strong a networking background. So learning networks and then using that to understand how VPCs work in AWS, really powerful. Learn a little bit of code because it makes understanding how these services work a lot easier. And then the next thing is learn by doing. AWS is free tier. So do Azure and Google's cloud platform. Use them, abuse them, create a little tiny web store for your Star Trek merchandise or whatever it is that you want to do. It's so much easier to understand these concepts when you actually get your hands dirty. And don't be afraid to fail either. There'll be a lot of failing. You can't possibly learn something without things going massively wrong at some point or another. And then the last thing I want to say is collaborate and communicate. If you're, this actually applies whether or not you're a noob. So if you're a complete noob, reach out to other people, learn from others, ask dumb questions. Maybe Google a little bit first, but ask dumb questions. There are tons of people out there who have struggled through something and would be happy to help someone get a leg up on this before they struggle through it too. So don't be afraid to reach out. And then if you're not a noob, if you're in an organization that's moving to the cloud and maybe you're a little bit newer, communication and collaboration is very important across teams. So we already talked about how cloud security moves kind of in an AppSec direction. So you might be working a lot more closely with your dev team. And if you're not, maybe you should be, because security is something that should be kind of a mindset and not just a job title. So whatever teams are moving into the cloud should have security in the forefront of their mind, or at least maybe second or third and not, fifth or 10th or something like that. So learn to build bridges with your team members and leverage those relationships to incorporate security into the cloud as you move onwards and upwards. And that's all I've got. I'm done. So I have no idea why PowerPoint suggested this image, but I'm just going to go with it. It doesn't understand my nerdiness. So with no further ado, enjoy the rest of the con. And thanks to all my friends. Thanks to BSidesPhilly. It's been really awesome. And yep, nerd on.